Hello. What I'm about to present to you is my end of rotation presentation that I gave at the end of my co-op. So my name is Malik Freeman. I was a BPS co-op for Bosch Rexroth. BPS stands for Bosch Production Systems. I'm currently a student at UNC Charlotte. Mechanical engineering is my major, and I am a senior. I just completed my first rotation this August to December 2021. I was a BPS co-op, but really I was under the TEF team, Technical Engineering Functions. It was pretty much the same thing, just within the realm of the company. The team I worked with included Mike Tyner. He was kind of the boss. He was a real great guy. And then the others, we've got Florian Eichhorn, Tazeen Hossein, Derek Karpovich, Benjamin Miles, and Jasmine McQuillan. In this slide, I've just got listed nine of the things that I'm going to cover. Now, I did do more stuff during the co-op, but these are just the 9 things I felt were big enough to put into my presentation. Okay, so the first thing we're going to cover is the gusset tab braking tray, one of the very first things I work on during my rotation. So first I'll cover what a gusset is. A gusset is essentially a bracket, a right angle bracket, kind of L-shaped, that can connect 2 pieces of aluminum extrusion or say wood together, and just say they're very important to the builds here. They essentially allow for the connection of just about anything that Rexroth sells. So this pressing table is very important. And any efficiency on the pressing table leads to efficiency everywhere else. What was already there is this 4-pronged press that will allow you to break the tabs off of 4 gussets at once, as opposed to just one using a regular arbor. But you would still have to line up the gussets, and it was just rather tedious. So I was able to design and machine this tray here out of aluminum and actually put a pin interference fit connection to this arbor table. This will allow Alfred, the worker, to align the gussets directly in there with no extra steps. He just slides them in, and then it also puts the gussets at a much better height for pressing them down with the lever ergonomically. And additionally, I stabilized the arbor table with just a couple screws in the back. So I made the whole press just easier for Alfred to use. Next up, I've got the improvement for the AMAT greasing station. Now, what I did was I installed this rail here onto what we call the greasing table. And essentially what it does, it takes grease pumped in from here and it spits it out here. And then there's a little roller that you can slide on the track to actually take this grease and apply it to the little ball bearings within the roller. What was already there was this smaller one for these smaller rollers, so I installed a bigger one for the bigger rollers, and it saved, I think they said they could do in 30 seconds what previously would take at least 5 minutes to grease up these rollers. And so at the time I was doing it, I thought it was kind of just screwing this thing into the table, but there was a lot of calibrations I needed to do. I need to make sure it was aligned perfectly right. And I had to make sure there were not even any bumps in it. Thank you to Derek on that one. He was a lot of help, such that it didn't damage the actual rollers. And then even after the installation, more work still had to be done. Had to go through the whole process release, basically meaning I had to edit the work instructions, I had to train the workers who were going to use it, and I had to go get signatures from a bunch of different people to sign off on it and say that it was up to Bosch standards. So it led to time savings and, as a result, cost savings. Here we've got improvements to the 8mm ball screw line. So one of my mentors, Tazeen, she actually had me implement this design from Germany into our Charlotte plant. Now, the 8mm ball screw is a screw with an 8mm diameter, it's pretty small. Some of the other ball screws we made, we were able to use just the bigger process and it worked just fine. But for the 8mm, we were kind of lacking. Previously, we were using the arbor press that we used for the the big screws, it just wasn't working all that well. But Germany had this design for a pressing stick. You wrap it around the table and press down on the ball screw, and it straightens it. So I had to take this and size it down with correct measurements, lengths, widths, to fit onto the Charlotte line, which is pictured here. So here is the CAD model I made for it. CAD was very instrumental in this particular one. It did all the measurements for me. It allowed me to see what would work, what wouldn't work, and I was able to 3D print 3 rounds of prototypes. Here is my last one that was perfect. And once these things actually get machined, the ball screw line will be fully updated. So I had to do that. I had to get the floor workers a new torque gauge and metric units. Everything we did was in metric, but we didn't actually have a metric gauge. So I got that for the process, and then also I needed to provide a new catalog to the workers on the floor, an updated one. Okay, next we've got the torque tester safety improvement. This torque tester is something that was previously used, but by the time my rotation started, it was put out of commission due to the fact it didn't have a safety stop on it. If somebody's working all the way down here and the power button's all the way over here, and well, by the way, this is about 2 yards distance here, maybe even 3. If something happens, this thing's spinning really fast like a lathe. If you get caught up, that it's gonna hurt. So they wanted me to install the safety stop, and had to mount it with some company provided aluminum extrusion. And the extrusion mounting was actually a little bit unstable. So I mounted these aluminum L shapes that I milled out, and I screwed them onto the extrusion. It made the whole thing stable. Maintenance wired the thing up, and it works perfectly fine. And now we can use the torque tester again and operate it safely. So next up we have the IMSC. That's just a special type of rail that they're beginning to implement down in Charlotte. They're already doing it over in Germany. So my boss, Mike Tyner, he gave me the German work instruction. Well, it was German but translated to English, and he wanted me to like actually translate it with English language that we use down here in Charlotte, not just Google Translate. So I translated the work instruction, and in the process I had to learn about how this machine works. This is a machine, by the way. There's just this cart here, and it's got the actual apparatus here. What this does, it cuts rubber strips. Cuts rubber strips with magnetic barcodes embedded inside it. So it just gives that particular strip, it gives better location information than a non-magnetic strip could give. It's for really precise applications, which and it's kind of expensive, which is why we're just now implementing it, and it won't get too many orders. But so my part in this, I had to localize the work instruction, take it from German translated English to fluent English. I had to learn how this thing works, had to set it up in this location here. Of course, I had the help of one of the other co-ops during this process. And I also had to, I had to begin the process release, but I wasn't able to finish it. I released the work instruction, and I believe that's it. Also, I conducted training, but it was unofficial training, not really for the process release. It was kind of a practice training session. Silver cut saw number 2. So this location already had a silver cut saw. They had 2 of them. One was functional, one was not. This is the non-functional one. It was sitting off just on opposite of the number 1 for I think 4 years. They actually used it as a kind of a spare parts machine. But one of the new engineers, Florian, actually, he took it upon himself to bring this thing up to speed. So he had me help him out during the whole process. And it took more than the whole 4 months I was there. but I was able to see it go from absolutely nothing to completing one test cut. So this blade right here, it cut these rails right here. I'm sorry, it's a little hard to see, but we were able to do several test cuts. We were able to prove the thing was working. It was connecting to the system, and hopefully soon in the future, we'll be able to put in true orders. And with this, it could potentially double the output of the rail line, potentially. There were a lot of roadblocks in setting this particular thing up. You had to work with several different departments, including those in Germany, which, as I might have mentioned, they are 5 hours ahead of us. So if you don't send them an email by noon, they're not going to get it until tomorrow. So it can be like playing tag with them. We need support from them. We also need support from other departments, such as logistics. Now, some people in logistics, there will be people over there who need stuff that only they know how to do, that we can't do it. And even if we did learn how to do it, it really would be impractical just for this one thing we never need to know how to do. So we had to work with them. Some of them would have other urgent problems they're already working on, but we needed them for our urgent problem. It could be a little frustrating, but it was rewarding in the end, seeing this thing finally do its cutting. Okay, so these things go along with the silver cut saw to make up one entire rail line. So they are the profiler and the imprinter. Right here is a profiler. Basically just takes the end of the rails that you saw in the last slide and it gives them a chamfer. It takes away that sharp edge. And the imprinter, that's this right here, it's kind of like it's basically like a printer. It prints and it'll print a little barcode with just a needle. It's like an impact printer. Imprinter. So these things, they're not operational yet, but we took a lot of steps in order to get them operational. Sometimes you just run into not necessarily a roadblock, but just something you wouldn't expect, like a bag full of steel shavings just inside the machine. You got to take that out and clean the machine out. And with this as well, we have to work with CI, MFO. We got to get somebody on the floor to tell us where we can put it. We got to get maintenance to tell us why we can't put it there, how we have to adjust it, and also to do tune-ups on it if it's something we can't handle. And then IT, we needed them to fix the computers or give us an actual computer, new keyboards, new monitor, a mouse, software. But once these two and the silver cut saw are up and running, it could potentially double the output of the plant. So logistics center is essentially a fancy word for a warehouse. We had a warehouse down the street. Occasionally I would have to take a little field trip over there and either do some work there or just pick something up. So one of the major things that Bosch sells, they sell aluminum extrusion for framing. Is basically 2x4s made of aluminum. And they also sell linear actuators such as ball screws like you would see on a 3D printer. They sell belts. They sell planetary screws, although we don't do that at the Charlotte location just yet. And we also sell rail lines for like sliders to go on. So most of that stuff is actually kept in the warehouse, and when it needs to be worked on, they ship it from the warehouse to what they call the plant, where the office was, where I would work every day. So the stuff would go from the warehouse to the plant, and that's when it would begin getting worked on. If say the TEF team or me as the BPS co-op needed some Rexroth material to put together in order to facilitate something on the floor, then I would have to put in a stock request from the LC and have it come to the plant, or I could go pick it up myself. But occasionally I would have to go to the LC. One of the first things they had me do over there was try to organize the shipment of Zebra stuff that they had just gotten. And if you don't know, Zebra is essentially workplace smartphones. They got scanners on them. You can scan barcodes, keep track of the inventory. So they wanted me to develop a system to keep track of the zebra inventory so that it wouldn't be lost, stolen. They suggested RFID or Bluetooth, putting stickers on them so that they know exactly where they are via GPS at all times, or within the building via triangulation. Next up, I had to assemble a workstation, like you see here. It's essentially just a fancy table. Now, it doesn't seem all that glamorous, but these things, they are, they're very valuable for the people on the floor. They ergonomics and efficiency. When you can put stuff on the table, when you can wheel the table around, you don't got to make as many trips. It's just much easier to work. And then with the added height of the table versus doing stuff on the floor, literally the floor, ground level, it'll just allow you to work longer and more efficiently. All right. Next up, we've got the Linode handheld marker. I'll let the video run for a second. Okay, what you see it doing there is using a needle to imprint some text onto a plexiglass surface. This thing, it's another style of impact printer, kind of like the imprinter. You can just put a code into the machine using like the smartphone or the tablet that comes with it, and it will just stamp it right down here. It's pretty nifty to see something like this in action. So basically, we were going to use this for one of the parts they were making on the mills out on the floor, but nobody knew how to use it. So my mentor Florian, he gave it to me. He said, "Hey, figure out how to use it and give it to him, and maybe make a bracket or something for it too." So I had to figure out how to use it. It wasn't all that hard to figure it out. You just go online. It was still kind of tricky. And then I made a bracket for this particular part. You just slide the part in, and then it'll hold it there consistent every time. It'll print the numbers that's called for on the part drawing. It'll print it, and then we'll have some happy customers. The old process that they would do, it would take a couple minutes. We were able to get that down to about 20 seconds. I had to configure the software, I had to configure the coding, had to teach the guys how to use it on the floor. And it'll save us time and therefore money. One of the last things we had to do as a whole department, we had to move the TEF department that was out on the plant, which included the lathe, we had a mill right there, 3D printer, a whole bunch of cabinets, bunch of tables, hardware. We had to move all of that to another side of the plant and then replace it with 2 giant mills to make space for 2 even gianter mills. Humongous mills. It was a massive undertaking. Throughout the whole process, we were out there taking measurements, laying tape on the floor. We were checking and double checking. We had to update the layout, and then we had to double check the updated layout. We had to have meetings with plant directors. With I wasn't present for these meetings, but they had to meet with the guys who would install the new machines, the guys who would move these machines you have here. We had to enlist help from maintenance, IT, to move all of this stuff. It's still a lot of physical stuff, and boy, it was filthy. But every time you left, you left the day feeling fulfilled, like you did a good day's worth of work. So, and as we were moving, we were also doing 5S of the new location. So all this stuff that was over here, it was all out of order. We didn't know what we had. We ended up throwing a bunch of stuff away. But when we 5S'd it, we sorted it, we set an order, we threw out stuff we didn't need, stuff we knew we would need in the future. We packed them up into drawers, buckets, we put pictures, labels, all of that. Made it look really nice, very presentable. Here we've got the end of my presentation. So some of the things I learned during my first rotation as a co-op, you gotta learn to solve problems as they arrive. For instance, with the Silvercast saw, there was a slight alignment issue that if we had taken the proper steps, the official steps to solve it, it would have put us back a couple of weeks, and Germany was ready to go on like an extended vacation. So we needed Germany's support in order to finalize it, but if we'd done the proper steps and they went on vacation, it would have set us back a month or 2. So we were able to just shim it up real easy just to prove that something unrelated was able to work. And then we had Germany's cooperation, so that as they were going on vacation, we could work on fixing that, but we could still be moving on. Additionally, like I just said, coordinating with Germany. Germans, they have, not only are they 5 hours ahead of us, but they've got different holidays, different schedules, and also different a different language. Sometimes it can be hard to communicate with somebody, and they don't know the exact words you need in English. You definitely don't know the German, or at least I definitely don't know the word they're talking about in German. It can be difficult, but it's very possible, and it is fulfilling. And with a company like this, you get the opportunity to do some traveling. My bosses, they've been to Germany, they've been all around the U.S., just going to meetings, events, meeting with people from this humongous company. So robust planning, prototyping, robust planning, I guess that could mean anything from having a good layout, which would have been much more helpful in the TEF move, and even just planning a project out. So like with the 8mm ball screw, I had a plan given to me by Tazine, and in order to implement that plan, I would go out, take the measurements, do the CAD modeling. Now that prototyping was phenomenal. Without access to the 3D printer, implementing that 8mm ball screw would have been considerably more difficult. I could just throw a model into the CAD and say, oh, you know what, this should work. I'd print it out and see, I could stand to adjust this, stand to adjust that. And really, I didn't lose anything. Just a couple of dollars worth of filament and some time. In that time that it took to print, I could go and work on something else. And then once the printing was done, I could go check it out, see if it was done, and boom, I could move on, do the manufacturing, and a whole nother day. Is really impressive what a good plan can do. Now, when you plan poorly, that of course impacts your performance, impacts what you're able to do, and then if you perform poorly, then if you have to go back and revisit it, even if it's not you, whoever's revisiting it, they will perform poorly in the future. So I really learned the impact that my personal actions take on the fate of myself in the future, the company, and whoever else is working behind me in the future. And additionally, being able to justify things. For example, when we were building the workstations at the logistics center, we didn't really have access. Well, we didn't have our own drill, our own impact driver. We had to borrow sockets, we had to borrow adapters, and it just made building these things very difficult. And there were about 15 of them to build, and they weighed more than a feather. They had some weight to them. So trying to maneuver all around them, put in about 15, 20 screws per each of them while drilling the holes without the proper tooling, it can be very difficult. I was able to convince the boss, Mike, to buy us a couple new drills, couple new drill bits, and some sockets. And with that stuff, we were able to actually do more of the work that we really should be able to do. So when you have the proper tooling, you can do the proper work, and vice versa. When you don't have the proper tooling, you can't do the proper work. You've got to run around begging people, can I use this, can I use that? So not having to beg people, just having it, it allows you to do better work more efficiently, and you feel more fulfilled in the end. I say that to say, I learned how to justify stuff. You can still get stuff you want if you're able to justify it. And of course, probably just don't want to buy a stock ticker for the office. But they were talking about that, and I think with some thought we could justify how to do it, and I could actually see them buying it if I was able to justify it. All right, well, that is the end of my presentation. Thank you for listening to it. I hope you enjoyed it, and I hope you consider a co-op, particularly Rexroth.